As usual, please go to the Science2 homepage on Canvas. You're looking for the tasks to complete for Unit 2, Lesson 6, or U2L6. That's what today is. And you'll need a lot of links that are on that, so look for that either on the weekly calendar page on the homepage or under assignments. Sophia Eddington, how you doing?
I'm doing good so far.
What did you do over the long weekend?
I kind of just relaxed.
Review homework. Just to share my screen here, you had to submit your drawing of the elliptical and circular orbits. I'm going to put Molly on the spot here. Here's her drawing, which is awesome. I like the apple and tree names for the planets. And again, this is what your drawing should have roughly looked like, kind of like a little egg inside another egg or something like that. And then you should have shown your math here exactly as she did, including units, which is great. So I'm seeing submissions from almost all of you. Again, if you haven't uploaded your photo yet, please make sure to do that and let me know if you need help. You had to complete the little quiz based on the simulator. If you couldn't get the simulator to work, just let me know and I can help you through some of that, or I can just excuse you from this. The main point of this was to show you that when you increase mass, it draws the orbiting object closer in because mass is proportional to gravitational force. And when you decrease the mass, it floats away. And the other thing I like about this is that you can see in elliptical orbits that the speed isn't consistent, that it moves faster when it's closer to the source of gravity and moves slower as it moves away from it. That's going to be one of the key takeaways from that chapter 5.12. And then you had the Ed puzzle to watch, which was just me giving a lecture. It's showing that Alex, Sophie Forrest, and Samantha haven't done this, but I'm wondering maybe if you just did the video and submitted the Google form. I will go check the Google form later as well. Any questions or anything you found difficult about that you wanted to look over? All right, we'll take part in a short little Kahoot to review. See how you do on this material. I think it's just 4 questions. You all know how this works. Optimize my screen here. Okay, game code is 9267341. Please use your name or something close to it so we know who everybody is. Since most of us are here, I'll get it started. For whoever is having trouble getting on, remember the game pin is always on the bottom of the screen. You can still join. Okay, here we go. Just 4 questions. What is tangential velocity? Very good, interesting. We're kind of torn between 2 options, that being pulled to Earth's surface, that's just normal gravitational force. The correct answer, yeah, is moving parallel to the Earth's surface at all times. So it's sort of a circular falling motion. That combined with being pulled to Earth's surface is what allows orbit to be possible. Okay, Quinn in the lead, here we go. True or false, the moon consistently orbits Earth at a consistent velocity or the same speed at all times. Very Very good. Wow, interesting again that we're pretty torn. The moon actually does have an elliptical orbit, which means that its speed is inconsistent. It goes a little bit faster when it's closer to Earth, a little bit slower when it's further out, and that's why there's about a 50-minute delay with every moon rising every day, right? If it wasn't that way, then the moon would rise at the exact same time all the time. We'd be able to set our clocks to it, but we can't because it varies. All right, Wiley in the lead now. Here we go. Question 3. Increasing the mass of a planet would cause satellites orbiting it to do what? Relates to the homework that we did. Very good. Most of you got this. It would orbit a little bit closer. Again, remember, mass is directly proportional to gravitational force, and so it would increase gravitational force. Wiley's on fire, in the lead. Last question. What is eccentricity? Very good. Again, a little torn, but that is a measure of how round an ellipse is. This is something you did on the homework where you had to calculate the, right? Remember, closer to 0 means it's more circular, more round. Closer to 1 means it's more elliptical, a little more squished. All right, Samantha in third. There we go, Quinn. Nicely done, Wiley. Great. All right, any questions or comments on that Kahoot game? Wiley, I hope you crush your water polo tournament like you crushed that Kahoot. All right. Next task then, if you have the tasks to complete open, we are now on step 4, gravity visualized Edpuzzle. There is a short video I'd like you to watch. It's just a portion of a much longer video. It's about 4 minutes and 48 seconds long. There are 4 questions associated with it. And so please just click on the Science2B gravity visualized Edpuzzle link and work on that. I'll allow 10 minutes to complete this, but again, I'll keep an eye. Once it looks like most of us are done, I'll bring us together. If Edpuzzle doesn't work for you, or if it freezes, I know some people it freezes after the first question, I have a link underneath in that second bullet point to just the video on YouTube. Just watch the first 4 minutes and 48 seconds of it, and then there's a link to a Google form which has the exact same questions that everyone else would be answering in the Edpuzzle. You can complete that alternatively if you can't get Edpuzzle to work. So 10 minutes to tackle that. Let me know if you have questions or need help. We'll come back together when it looks like most of you are done with it, or at 10 minutes. Go for it. All right, kiddos, come to a stopping point. Looks like most of you have completed the Edpuzzle. If you haven't, it's okay. Just try to wrap things up. Or again, this is not a graded one, so just come to a pausing point. We'll review the questions. Pretty cool, huh? Had anyone ever seen anything like that before, using fabric to mimic orbit? I think it's really helpful demonstration that, in my opinion, helped me wrap my mind around this idea of Einstein's idea of gravity and bending space-time and that kind of thing, which this directly touches on. So let's see how we were feeling about each of these questions. Can break them each down. First one was Einstein didn't think of masses as in space as feeling or experiencing gravity, but instead very good that they were bending space-time. And so he's using the spandex to kind of simulate that. He's not saying that the whole universe is spandex. It's more just meant to represent what he means by space-time and is a convenient way of showing how things are attracted to each other. So he placed a small one on the edge. It was pulled towards the center. But when he throws it sideways, it begins to orbit around that center of mass. And what he has given it by throwing it sideways is that same term, tangential velocity, right? So at the same point that it is trying to fall down to the center, it's also moving sideways. And so it's falling around the object. And I think that really, I don't know, this demonstration for me really helps me grasp what exactly is going on with orbit and those two forces acting together. So he kind of touches on how, and he does a cool demonstration where he throws a whole bunch of marbles in two different directions, which is what in nebular theory our solar system looked like when it first started to form. There were different planets and rocks orbiting in different directions, but eventually there was a dominant direction established. Everything started to hit, smack into each other, a lot of collisions, but eventually one form of rotation became the dominant one, and that's why all of the planets in our solar system orbit in that same direction, which is kind of cool. And then by pushing the larger marble and the smaller marble together, he was mimicking a planet and moon situation. You could actually see the smaller one orbiting around the larger one. Doesn't work perfectly, but gets pretty close, which is awesome. Any other questions or concerns on that video? All right. Then the next thing we're going to do is you at home are going to try to do that same activity. If you look on the tasks to complete list, this is step number 6. Step number 5, gravity visualized Flipgrid. And just click on that link right there. It'll take you to this assignment. You're going to need a large bowl or pan or pot or something like that that's large and round. You'll need a t-shirt or a cellophane wrap or a towel, or if you have a spandex shirt, you can use that to drape over it. You'll need clips or string or a belt to kind of tighten it down. You'll need something small that you can roll. So in your science kit, you have a little marble. So if you got your science kit, you can get in there and there's a little glass marble you can use as your planet. If you have something larger and heavier to put in the middle, you can. It usually doesn't work though to put something heavy in the middle and move it around because of how small the space is. So what I recommend doing is actually just to mimic your center of gravity, the force in the middle. You know, in the video, he puts a big heavy weight. You can just push into the middle with your finger or grab a knife or a fork or something so your hand isn't getting in the way of your orbiting, but just push into the center. That'll be your main source of gravity in the center. And then you can get a marble or a grape or an olive or anything round, a ping pong ball, whatever you might have at home, and throw that sideways. And your goal is to give it some tangential velocity and see if you can get it to orbit around at least once. So in your video, you're going to do 3 things. You're going to show your setup. You're going to place your little round planet object on the edge and let go, and it should just fall towards the center. That's your first demonstration of gravity attracting to the center. And then you're going to give it tangential velocity, throw it sideways, and see if you can get it to orbit just once. I have a demonstration video like usual, and you can kind of see in this little thumbnail here that how I'm pressing in the middle for my source of gravity, and I've got a little kind of ball there to represent my orbiting planet. So I'm going to give you about 20 minutes to work on that, and then we'll check in. Let me know if you can't find something, or if you're not sure what to do, but all the instructions are on the assignment. You can watch the demonstration video to get an idea of what you need to do. And again, you can be creative with the objects that you have for rolling. If you really can't find something small and round, you can use a coin if you really need to, just to show the orbiting bit. But all right, 20 minutes. Let me know if you need help. So you're going to be watching, this is the assignment. It's a discussion board that'll be graded, and you're posting, you're going to watch this video. It's a SciShow video. It's about 4 minutes and 15 seconds long. It's about how we get satellites into space and how we get them to stay in space. But they bring up an interesting problem in that we're launching new satellites into space all the time, but there's a lot of old ones up there too. And basically, it's a little kind of look at how we deal with older satellites. They're either deorbited, so they're brought back into Earth's atmosphere and they burn up, or they're brought back down to Earth's surface, or they are essentially pushed out into what's called a disposal orbit, where they're much further out than working satellites, and they kind of just hang out there. But there's a bit of a problem with that, which you'll see in the video. So what you need to do is watch the video. There's one question to answer on the discussion post, which is how would you define decay, orbital decay, which they talk about in the video. Then the second thing you need to do in your discussion post is what's your opinion? Should we bring deorbit old satellites, crash them into Earth's atmosphere, or should we push them out into disposal orbit? Like, how do you feel about it, and explain why? And then I'd like you to just kind of read and familiarize yourself with something SpaceX is doing. I don't know if how many. Let me see my screen. Well, so SpaceX is starting up what's called a Starlink project, which is essentially to get high-speed internet to everyone on the globe. You could literally be on the top of Kilimanjaro in Africa, and you would get your 5G connection. And to achieve this, they're basically launching lots and lots of these Starlink satellites that have much lower orbits, right? Most orbits are about 1,000 kilometers or more. They're launching all these satellites up to about 550 kilometers to orbit closer to Earth's surface and emit essentially Wi-Fi connection that would be all over the planet. However, it's going to take about 42,000 of these satellites to make this possible, and they need to be orbiting in sort of a geometric pattern, sort of visualized here. And this is kind of a short article about what's going on with this, because some astronomers are concerned that all these satellites are going to ruin imaging from Earth's surface. So you get these kind of blips here. Here's an image of what this satellite looks like going across, that stargazing and taking images of that is going to be much harder. So I just want you to kind of skim over that article, familiarize yourself with what's going on there, and again, just share your opinion. Do you think that global internet is something that's worth achieving? And should we launch these 42 satellites? Because SpaceX is doing it right now. They just recently had a launcher. I think they launched something like 200 of them up into to start their orbit. So familiarize yourself with that and post to that discussion board. Any questions on that? All right, that is it for me, kids. Thank you very much. Have a good day.
Thank you. Have a good day.